Hello, everyone. Welcome to today's webinar. We'll do a bit of an introduction while everyone joins over the next few minutes. Today's webinar, GenAI and Localization, is jointly hosted by Intento and memoQ. As the title suggests, we'll be focusing on GenAI for localization. We're going to be having a look at what's been going on in the past year or so, and also getting some thoughts on what we foresee for the year ahead. My name is Marjolein Berends, and I'm a solutions engineer at Intento, and I'll be the moderator for this session today. Before I introduce our speakers, just a bit of general information for everyone watching. This webinar will be recorded. So if you signed up and you're here watching us right now, then you will be able to access a recording of the session later on in case you're unable to be here until the very end. And also, we will save some time at the end or even during the discussion as well for questions. So please, if anything we discuss sparks an interest, just leave your questions in the little Q&A box. You'll be able to chat to each other as well a little bit. Okay, so I am joined by two experts in the field. We have Balázs Kis, Chief Evangelist at memoQ, and we have Konstantin Savenkov, CEO at Intento. By way of introduction to the topic of the next hour, and mostly introduction to the two speakers as well, we'll be starting with a little overview from both of you to get a bit of a taste of your perspective on GenAI applications over the last year, and also how, respectively, memoQ and Intento have been approaching the technology. So, hello to you both. Balázs, if you don't mind, I'll give the floor to you first. From your perspective, what's been the biggest change or maybe the biggest focus you've seen at memoQ for GenAI in 2024?
Thank you, Marjolein. I'm really honored to be here, and thank you for having me in this webinar. Let me very quickly share my screen. That should do the trick. So I was already introduced. So I only included this slide as a precaution in case I need to say anything about me, but I was perfectly introduced. So thank you very much for that. The biggest challenge is what I have seen in the past year, past 1.5 years to GenAI application is to find out the right use cases, to find out what the requirements can be, and how the GenAI technology can comply with the existing requirements of translation buyers. And as you would expect with a new type of technology, there are all kinds of technology experiments in the wild, but it has a beneficial result, because what I have seen and this is no longer in the way of challenges, what I have seen at events and professional communication in the last couple of months is that people are really getting educated. This was something that was really and has been and is very close to my heart to get it to help people get educated on what these technologies, GenAI, even neural machine translation, various resources that you use in translation automation. So how these technologies work, what the opportunities are using them, what their limitations are. Because knowledge is power. If you understand how these systems work, you will be able to put them to your use, and you will have a really high level of power over them. And I'm also seeing that buyers, and these are buyers that we meet through memoQ, but they are learning not to adjust their requirements to what neural machine translation or GenAI can do. It's really important, because what happened at first is that everybody was not everybody. There were voices that said that, yeah, this GenAI technology can do everything, and let's throw out everything that we had before and use a large language model for everything. But that is far from being true. And when you automate translation, it's not an either or. You don't have to vote for one single automation technology and then use only that. So one main reason is that the language coverage is uneven. OpenAI only covers 50 languages. What happens to the what happens to the others if you insist on doing everything through a mainstream large language model? Doesn't mean that you decided that all the other languages don't matter. Speakers of those languages don't matter, and of course you don't decide like that. And not all requirements are equal. Translation buyers, fields where translations are used, localization is used, have widely different requirements. So as a result, and this is something that, because with the ascent of GenAI, the general public was introduced to translation automation. A larger portion of the general public was introduced to translation automation. So and it's important that this larger portion of the general public is beginning to understand that translation automation uses a combination of resources, which really need to be engineered as an ensemble to be really useful and to meet the requirement of the translation buyers. And memoQ was deliberately quite late in adopting GenAI in its technology stack. And the reason for that was we didn't want to integrate a kind of AI, a large language model, just because everybody is doing it. So we wanted to understand where the value proposition is, where we can provide real value to the customers, and the result was memoQ AGT, which produces LLM-based machine translation from that's an N-shot machine translation that works out of translation memory, corpus matches, and terminology matches. And the AGT technology takes these matches and produces, through an LLM, produces a good translation of whatever needs to be translated. And a year later, we acquired an integrated a machine translation company called Globalese, who are known for their custom models, AI-boosted custom models, and these also became part of the memoQ resource range. And the important thing to my mind is that this way memoQ can provide the full scale of resources that you can use in translation automation. So you have the right set of tools, even if you need to do most translations by hand, because one of your languages, for instance, isn't covered in NMT or the large language model, or at the other end, if most or all of the translation process is covered with full automation, that is also possible, and the mix of these is also possible in memoQ. So that's something that is really important to us. This is how I would introduce this. That's my take for the time being, and of course I welcome follow-up questions. Thank you very much.
Great, thank you so much. It's a really interesting overview of memoQ. I've worked with memoQ for about 10 years, and in the last few years, there have been quite a few developments there. So thank you for that overview. I'll go to Konstantin. What have been your observations at Intento? Obviously, I have a bit of an idea, but I'd love to see any shift or focus in terms of GenAI from an Intento perspective.
Thank you. I will. I'll probably take pretty high-level perspective here. Do you hear me? Right. So
yes,
we know that last couple of years, engineers got lots of new tools, large language models, prompts, RAG, vector databases, knowledge graphs, and other stuff. And I think the main question here is, are those just new tools to do the same, what we did before? Or there's a new opportunity to do something which was not possible before. And like with any new tool, it depends on how you use it, right? Because you can use hammer to nail things. You can use laptop to nail things. It's actually metal, quite heavy. Some people would even argue you can hold it with two hands, but likely it would take more time. Okay, it's a bit slower. So there are other ways to use laptops so that you are not comparing it to a hammer, right? And that's why I want to focus on how we learn to use LLMs, not like MT. So we can say that neural machine translation is data-driven automation. So what I mean by that is that an enterprise company typically has quite specific localization requirements and terminology, tone of voice, inclusivity, idiomatic translations, or accurate translations, lots of those requirements. And if you use stock machine translation, today it may provide you fluent translation, but it doesn't know your requirements. So it will likely won't follow them. In addition, if you translate in some narrow domain with specific terminology, NMT wasn't trained on such content, so it will result in mistranslation beyond what you can repair with a glossary. So such stock NMT will likely be good enough for use cases with low requirements, such as gsync, UGC translation, and so on. But for other use cases, technical documentation, UI marketing, you need to send it to human post-editing. Now, what you can do with NMT, you can provide your data, mostly translation memories, you can fine-tune it. And as much as your requirements are represented in this data, they will be learned and followed by the model. You have more data. So you have more data, it will follow more requirements. If your data is better, is consistent, it will follow more requirements. And the problem here is that the only way to improve NMT quality is provided more data. And many of your localization requirements cannot actually be learned from data because either they do not appear often enough or they're context dependent. And as a result, your approach here would be to pick the model that better trains on your data and then look at the output. And if for some use cases the output is good enough, then you just use it as is. And for other use cases, you introduce those post-editing workflows where you just send it to humans and they figure out what requirements are missed and how to fix it. There are some kind of more dynamic implementations of that. You can use quality prediction scores, certain threshold to decide when to send to humans. And that's data-driven automation. More data you have, better output matches your requirements, but the only way to check what's wrong with your translation is to show it to a human translator, and the only way to improve the quality is manual post-editing. So that's when you test your NMT at scale and see systematic translation issues are there. You use post-editing workflows. And for these post-editing workflows, for the cases of any other kind of human translation, companies likely have 95% of their budgets locked. So LLMs, they bring important capabilities, right? They allow to check what's wrong with a translation, and they enable improving translation for a specific aspect without learning it from data, by instructing. And that's hugely important. As I mentioned, 95% of budgets likely locked on human services, and they're often not spent in a good way, meaning that you're sending something to post-editing, which is perfectly right, and in other cases, post-editors do lots of boring, repetitive tasks, such as just going through pages of translation and changing tone of voice and gender forms and stuff like that. So now we can instruct LLMs, and this is new way to improve quality. It means that if we take the same process, which we consider for neural machine translation, now we can use LLMs to identify those systematic errors, those weak spots of machine translation, and we can use LLMs to eliminate them. We don't use just LLMs, we use AI agents, which is basically, when I say we use LLM, we can mean we just do prompting, right? But you cannot really put many things in one prompt. So we found that the way to kind of have it in a reliable way and also have it be able to maintain it over time is to kind of split it into certain entities which know requirements, they can check those requirements, they can improve or escalate to another agent. And what we've done in the last probably 3-4 months, we deployed a platform for AI agents, and we're working with a few customers to see what kind of systematic machine translation errors we can eliminate. And potentially that opens up a way to actually automate translation where requirements are known in its entirety. Yeah, thanks.
Thank you, Konstantin. That's super interesting. I was recently talking to a fellow member of the industry, so I won't take credit for this, but they mentioned it's funny how suddenly AI is this big word and we have loads of eyes on whether we are using AI and how we're using GenAI and localization, whereas actually you're talking about an industry that's probably one of the first to adopt AI and automation even before everyone else was. So it's great to see so many different advanced directions it's taking in the industry. Right. I want to go into our discussion. I think that's a nice segue into it. I want to start by going back to the basics a little bit. GenAI technology can solve many types of language issues, as we've already seen, and we'll be discussing today. But a very common and popular application we currently see is GenAI as MT, so as machine translation. So that means replacing our more conventional machine translation models with GenAI models here, large language models. Now, for years, Intento has been including GenAI providers already in our State of Machine Translation report, benchmarking GenAI providers against machine translation providers and all in one mix. And that has shown a bit of an upward trend in quality and in performance already for certain language pairs, certain content types. What's been your experience? I'll start with Balázs first. What's been your experience with this approach for GenAI as MT? Could there be any benefits to it?
Thank you. Actually, we have been from the get-go slightly skeptical towards using GenAI as a zero-shot machine translation solution. And we haven't, except for some external integrations through Intento, for instance, we haven't implemented any kind of zero-shot GenAI-based translation ourselves. There have been studies, there have been voices saying, if you look back at the recordings of some of the webinars that I was involved in, one of them was in Hungarian, so that would actually present a challenge. People there were saying that GenAI MT will completely replace neuro machine translation on the short run, but I think I know of quite a few use cases where this isn't going to be the case, simply because if you look at GenAI, the data requirement to building an LLM or the coverage, again, I'm back at the language coverage of mainstream large language models, there will be situations. There are situations where this is not the case, and the picture is more colorful than that. For instance, and this is something that we both Globalese by memoQ and memoQ are paying special attention to, situations where you simply can't go to a cloud-based solution simply because of your security requirements. And for instance, Globalese has had experience building efficient NMT and models from a limited data set. And often the translation buyers who have the most stringent security requirements also have, in many cases, the kind of quality requirements that make no compromise on quality. I'm talking about pharma, I'm talking about life sciences companies sometimes, banks sometimes, and not mentioning the gaming industry that has very special quality requirements towards both the source content and the translations. So in those cases, it's always a combination of resources, and even if we are looking at either zero-shot or n-shot translations, where you start from something, so start from a match, start from a machine translation suggestion, and then use the GenAI to adjust that, or use the GenAI to spot errors, like Konstantin said, where you can use the GenAI system to spot non-compliance with certain requirements and offer corrections, or decide to send the piece of text onto human post editing. There will be differences in how these systems behave in various language pairs. For instance, we had this experience with AGT, that there are some language pairs where it's a no-brainer using it because the output is so good, and there are other language pairs where the testers said, and we have measurements, they say that yeah, you need to use these results with a pinch of salt, and all this in a localization situation where, for instance, you have a gaming provider, you have a life sciences company that needs to localize the same thing into 100 languages. And that's not going to change, because you cannot go with different instructions for a type of medication, depending which country it's going to. So that is our take on it. And one of the interesting things we are working on is because for the Globalese AI boosted engines, we still rely on cloud-based LLMs. We are planning to maybe already have, I haven't asked my colleagues about that, experimenting with smaller language models that can be used to boost the engines and can be trained or fine-tuned through locally available data, so you don't have to go to the generic general purpose LLM, because in some security requirements, even the more stringent terms that, for instance, Azure OpenAI offers when you access OpenAI systems models through Microsoft, even that won't be enough. And then what do you do? So this is some of the things that we have experienced with these, and I'm really curious to find out what the experience of Intento and Konstantin was.
Yeah, definitely. Super interesting. It sounds like filling the gaps and already kind of looking into some of the things that we're going to be covering later on in this discussion around combination. But yeah, Konstantin, go ahead.
Well, we see that there are cases where we indeed use LLMs just for translation, where we just could not address that before. I think two most important is one is when we don't have enough training data to learn some requirement from, but we want to instruct model to follow it, or this requirement's not really possible to learn. For example, it's all about, for example, working with numbers and currencies, or working with very specific style for tone of voice, say in Korean language. It does require lots of sophistication. You don't need to build like the whole agentic workflow sometimes for that, but you can just with LLMs, you can just add these additional instructions. Or like, for example, if you're translating UI, the easiest way you can just tell a model that you're translating UI, and suddenly all your short strings will be translated much better than machine translation does them. And second case is everything related to low resource language translation, including cross-dialect translation, because there are typical situation in enterprise. I'm not talking about really low resource languages, because we don't deal a lot with them from business perspective. But we often have a situation when a customer needs to support few dialects of Spanish, but they have most of the data just in one of those dialects, and then we can customize an empty model and then use LLMs for cross-dialect translation. So those, I think, two main instances. And at the same time, we see that definitely machine translation is still, neural machine translation is still the king when you have a lot of training data, millions of segments, just because training LLMs is expensive. And we're working on certain ways to improve that. We're looking how we can kind of condense big data set so that it can be efficiently used for LLM fine-tuning. At some conferences, someone used a good word that how we make linguistically diverse data set, less repetitive, so that we spend less money. But in general, if you have lots of data, then still the best thing you can do, just throw it at neural machine translation, this kind of transformer, and see what it learns from this data, because it can actually learn quite a bit.
Definitely, I agree. I think just to add there as well, I think a very common application of GenAI as a translation agent is to transcreation use cases, maybe as well. So more creative applications. I think for years it was common knowledge that, you know, for very creative translation, our neural MT just doesn't cut it, can be creative like that. And then GenAI comes into the picture and is actually, pendulum swings the other way and it's super creative and has hallucinations, and that can actually be used to our advantage as well, I think. Okay, so we've spoken about GenAI as MT. I think it's clear that neural machine translation still very much has its own place in the localization realm for specific use cases, whereas GenAI can have a very different kind of application. Could these technologies somehow complement each other? Can they be combined? Do we see any benefits to how we can combine the two technologies there? Balázs, I'll start with you.
Oh, thank you. Yes, so this is practically we have been experimenting with like from the get-go. That's because for various reasons that Konstantin also mentioned, where what you need is really accurate translation. Then you need to start somewhere that looks like an accurate translation, have the LLM boost it, or in some cases, like again, we just heard an MT engine trained from rigorously vetted bilingual, multilingual data, parallel data, simply performs better. And sometimes, and there are also situations, and there are always situations where the human needs to have a say. And when the human needs to have a say, the human needs to be able to have their say in a very efficient and comfortable way. So sometimes you just need to touch up a translation. Sometimes you need to replace the entire translation. And for that also there are various technologies to help with that, to speed that up. For instance, and that's where something that I have learned still in engineering school, which happened in the early 90s, mind you. In the early 90s, I already had a 2-semester course on neural networks. It's the mathematics was there. People knew how to train a transformer, how to build a transformer. Maybe the mathematical methods were refined, but the real revolution with that came when in the early 2000s, someone figured out how to run the whole thing on GPUs. So back at the time, we were told that, yeah, if it ain't broke, don't fix it. That means that, for instance, if it comes down to the human to have to write up something, then, for instance, memoQ has a lovely predictive typing engine feature, and that is what runs behind that engine is a very simplistic statistical model. Do we want to replace it with an LLM? No, because it's efficient, it's very fast, it speeds up the human considerably, and it uses, I don't know, we didn't count, but 1/10 millionth of the resources that would be required by an LLM to do the same thing. So And this is what happens in the various automation technologies. So we use the translation memories and then apply the LLM to touch up the translation, adapt the translation. We use an NMT engine, then boost the translation, then apply terminology to it. And this is par excellence what it means to combine those resources. So the gist of my answer to this question is that not only does it make sense, that we do that all the time. So, and I'm really eager to hear what Konstantin has to say about this.
Yeah, thanks, Balázs. So one thing I mentioned is that when it's just a vast majority of data, going with NMT is kind of good way to capture lots of value from this data. Then I think most important part for us requires a bit context on our business is that kind of our approach is as follows: is that when a big company runs localization, they need to actually localize experience for their customers, for their coworkers. And if you look, this experience comes from many touch points, like website, application, live chat with customer support. On each touch point is some software system, and many of them require real-time translation, because either content is dynamic or it happens on demand. And for those cases, large language models just too slow as we speak. There are some positive developments. We just maybe a week ago had a webinar with Google where they announced some of the faster LLMs. But still, for real time, we have to rely on neural machine translation. And we even implemented some kind of interesting mechanism how we can leverage LLMs in real time, where we have like a first pass translation with NMT, and then we can do second pass kind of in the background a little bit with LLMs. And last thing to mention, it's also important. What we learned when we were working with Google to evaluate the new models is sometimes we think that, okay, NMT kind of reached its heights, and it's kind of frozen, and done. Any kind of further development will go with LLMs only. If you want to get the latest stuff, just use LLMs. Well, it's not true, right? Because companies who develop models, they don't kind of LLMs. No, there's lots of kind of cross-pollination between those technologies. And what we've seen, what we've shown last week is that over the last 6 months, actually, Google NMT improved quality quite significantly. So we see that NMT technology is also developed, and we always need to check that where they are.
Thank you. I think I was just checking the Q&A box during the discussion. And I think there's been an interesting question that kind of ties into what we've been discussing. And I think because it mentions AI agents, so I'm going to ask it to you, Konstantin. Regarding AI agents in LLMs, how can you ensure that their checks produce the desired results without humans in the loop? Also, how are they trained to produce them?
Well, that's all. It's important to remember that there's perfect quality and there's human level quality, right? And quite well-known thing in the industry, we found it when we run our own evaluation of automatic LQA of how LLMs work for evaluation. Are the same, is that if you pick a consensus of a team of linguists and compare it with LLM, there will be higher correlation between LLM and human consensus than correlation between human translators in this team. So all judgment about translation quality is most of it is kind of a bit non-deterministic. Let's say this way. There are some hard requirements, and these hard requirements can be, as we see, can be checked with LLMs. How we trust them? Well, we don't just run this, whatever prompt on 1 or 2 sentences and suddenly trust this model. No, we built a data set. We do like with engineering, we do QA, right? We built a test set, we run this test set, then it's deployed. And I think a good, we see first cases which kind of prove this point. You may have seen in some of our social media, not long ago, we launched with one of our big customers in media industry, we launched translation of business news into Korean with AI agents by making sure that all the hard requirements are met. And it's suddenly possible. It was never possible without LLMs. Now we can do that.
Definitely, absolutely. Going back to how we're combining GenAI with MT, have we seen any real life use cases, any real life applications of how we're doing that? I know that we're talking for the past 30 minutes about something very theoretical, and but how are we actually applying that in real life? Do we have any customer use cases, production use cases that we're focusing on? Let's see. I think we can start with maybe Konstantin.
Yeah, so one that I mentioned is just the most recent. It always we thought that this kind of high risk domains such as like stock market news translation is will be like almost a holy grail in terms of accuracy and reliability, and we suddenly we managed to do that with LLMs, and there were lots of focus on accuracy in numbers, accuracy in company names, accuracy in tone of voice, making sure that the language doesn't become legally binding where it should not be. So all those quite nuanced requirements which we're able to meet. Then we have a number of cases where some of the terminology is not learned by neural machine translation. So, and this is common word terminology. So we need conjugations, we need morphologically aware glossaries, where we tried to use some of the neural machine translation engines, which kind of advertise this functionality. But what we found is that when the text is formatted, this functionality starts to be less reliable than with plain text. And that's what we addressed. That's actually kind of standard agent we have on the platform, which is basically morphology glossaries, common word glossaries, which are supported after neural machine translation with LLM rewriting. It uses retrieval augmentation to retrieval augmented generation to retrieve all necessary terms from the glossary and write text. And then maybe a third thing to mention, we also seen in a number of cases, and that's what we use a lot internally for automatic LQA, that if you just add kind of a reviewer agent, which just instructed to check translation and improve it if it's off, it adds lots of value and lots of accuracy, both for translation and for LQA. So a small thing to mention, in addition to that, actually, the first application of LLMs at Intento was entirely internal. When we work with a customer, we train like a handful of transformers, then we compare them with probably 10 to 20 stock models, and all the way for the kind of final choice, we had to ask a customer to provide their subject matter experts or linguists. And we, at some point, we ran quite a big retrospective study to see if we would have used LQA using LLMs, would it change the choice of the winning model? And we've seen that it would almost not change the choice. So meaning that for choosing the right model, LLMs are very accurate, and we actually switched all our this kind of AI implementation phase solutions to LLMs as a judge of what's best.
True. Been doing that for a while, and it's saved us a lot of time, definitely.
Lots of money
but
for customers.
that too. That too. Balázs, any real life applications of memoQ as well?
Absolutely. Yeah, I was thinking because when it comes to providing translation automation technology to customers, what has been our objective, again, I could say in the last 20 years, is that to make it as seamless as possible. Now, if you have a complicated combination of more than 5 or 6 types of resources that have to be combined in order to produce the sufficient level of automation, that is a challenge. And that's actually memoQ AGT is one of the products of this effort that we have been making, because it's basically a RAG application that uses the existing resources in memoQ. You don't have to have a neural machine translation engine connected to your translation management system. You just use whatever resources that you have, including terminology, including corporate TMs, and then the LLM will do the kind of work that translators have been hating for, and I can say that because I have done a lot of translation using that. And one of the most hated moves a translator has to do is adapt translation memory matches, or patch together a sentence where you have like whatever 5 terminology matches, and you have to work the translation around them. And this is something that AGT will do for you. So what does that mean? That means that there are some LSPs already in North America and Canada that report significant savings using this RAG type approach, simply because these monotonous moves that a translator needs to do are automated. Again, this is not a judgment, not a kind of judgment that we are not using by default. We are not using the LLM to quality check. It is possible, obviously, but it's not the default part of the system. Although when you talk about translation and when you learn about translation, you learn that actually while translating, you make a whole lot of decisions, even translating one sentence. But these are the reports that get back to us. The mainstream LSP work, mainstream translation, starting from pretty traditional resources, is sped up, is made more efficient drastically, while it is possible to meet the same level of requirements. We also have internal applications, and that's something that was pretty much I wouldn't say 100% impossible, but it was pretty impossible. So you know what an RFP looks like when you need to submit an offer to a large corporation to win a business or sell technology to them, sell services. And that comes with questionnaires of, I don't know, 1,000 questions, maybe more. And we have been successfully using LLMs to populate these questions. We are using LLMs to answer information security-based questions, and then our Chief Information Security Officer is a big fan of these tools and makes very efficient use of them. So this is what is happening. So much so that we even created a spin-off company that created the tool exists, a cloud-based tool that will actually answer answer or help you answer your questionnaires using a large language model. And that means that we can process way more RFPs than before, and also it is possible that we will obviously do a retrospect on that. We haven't done that before. That is actually a common theme with LLMs, GenAI, that a lot of tests, a lot of measurements, a lot of retrospective examinations are still ahead of us, because mainstream GenAI has been with us for 2 years, but still that's a short time. But we expect that, for instance, with RFPs, our win rate will also increase. So just to name a couple of examples.
Thank you. I love how the implementations and the real life use cases are actually some internal as well, like not just for our customers that we're showing benefit, but we're actually making use of that ourselves as well. Specifically about all of those questionnaires, I'd love to hear more about that, because I spend a lot of time doing that.
Yeah, happy to later.
Definitely. I'm just conscious of time. I did want to go in a little bit into quality estimation, GenAI, but I also like to talk a little bit about just a general concept of quality and how what we expect from GenAI, what we expect from MT, what we expect from a combination of these technologies. I think we have long spoken about quality estimation, quality checks in the industry, whether or not GenAI comes into the picture. There is still always that age-old statement of what is quality and how do we set a quality threshold. Konstantin, you touched upon it earlier. We're quick to expect perfect quality from automation, from technology, from GenAI or MT. But human translation is not perfect. It's never been perfect. It's also highly subjective, I think, which is an important factor to take into account when implementing automation into language processes. So how do you think we can manage customers and companies' expectations? How can we help them navigate through it? What do you think, Konstantin?
I think Konstantin is muted.
I think you're muted, yes.
Yeah, sorry.
I wondered if it was me. No, okay. Yeah, I can hear you now.
I think it's important that quality, for at least for big companies, and this may be different for consumers, may be different for small businesses, or maybe they need just fluent translation and that's it. But we see that for big companies, quality is always quite particular. There's brand voice, tone of voice, terminology, and I think it's important to realize that quality is actually meeting requirements. It's no more no less. We can say that some of the requirements are basic. It's just having not having grammatical errors in translation and things like that, not having commissions, not adding stuff. But other requirements quite nuanced, and quality is always meeting those requirements. And what we see is that some languages are sufficiently supported by large language models, meaning that they don't do basic mistakes in those languages. And that's where we may say that, okay, in this case, if you have your requirements known, written down, we can develop a workflow which will meet them. It may require certain investment, may take some time and money to run, but we see that we can do that. Having said that, there's lots of cases where you automate part of your business which never was fully automated. You typically discover new requirements, and those requirements will not be met. And we have lots of situations of these kind of iterations. At the same time, there are some languages where we see that basic requirements are not met just because AI is not there. Not enough training data probably in this training set. And in this case, we would explain customer that yes, with LLMs we can maybe achieve better quality than with stock machine translation on those small languages, but they should not be expecting some nuanced requirements around tone of voice met. Like if you have specific tone of voice requirements for Icelandic, then probably we would have to disappoint you, because it would be quite challenging to tune workflow in this way.
Definitely. Balázs, what are your thoughts?
Actually, I'm pretty much on the same page with Konstantin. So it's crafting a workflow for a new customer when you sign up a customer as a translation management system. And it's sometimes it also takes a bit for the customer and for us to understand their requirements. But quality is basically boils down to requirements. Hopefully, ideally, well-formulated requirements. And I'm looking at the questions pane actually in Zoom, and some of the questions are around this the prompting issues, and in order for you to write an efficient prompts to check or elevate the quality of the output, you need to know what you want the LLM to check against, which means that you need to formulate your requirement, and that's sometimes it's missing. We have an entire team that if necessary works with the customer of better formulating or adjusting their requirements if something is not right. So yeah, I really don't want to take your time, because I think the same.
And Balázs, what I would add is that also what we see is that one thing is to write a prompt, right?
Yeah.
But then you need to maintain it, and the bigger it gets, the harder it is. And that's actually one of the reasons for us to go into AI agents, because as you using your prompt with your database in production, you over time, and just as like a tree, it's kind of you add layers, right? And then at some point you're adding something and something broken, what was working in the past. And that's why we see that the solution is to kind of make it modular, decompose it, so that, like with software, right, you are not writing your system in one function.
Yeah, I agree. We might not call them AI agents, but I definitely wouldn't write one prompt to check for all your quality requirements.
Yep.
So yeah, and especially it's interesting because it's a similar approach with pre-GenAI methods, where you also have the modules. So for instance, what memoQ still has is a regex-based quality checks, but you don't write one regex to check for everything. You write one regex to check for a specific issue. And I appreciate that LLMs and LLM prompts are much more complex than this, but it's a similar approach. You write a prompt for checking for one type of issue, which might be more complex or might more trickier or more difficult to check than what you would do with your regex, but it's pretty much the same approach, to my mind.
I think that. Sorry, go ahead, Konstantin.
No.
I think that links nicely to some of the questions that have been asked in the pane. I know, Balázs, you were looking at some of them already. So we have about 5 minutes left. I think we'll go into some of the Q&A. Since you mentioned around writing a prompt to look at a specific issue, I have a question here, and I'll ask it to you, Balázs. What errors do you think AI agents can detect and fix? And also, as a segue onto that question, are they able to replace human editors at some point, do you think?
So there's always a line that you draw, that you need to draw, that you detect when you look at what an LLM can do and what an LLM cannot do. So what an LLM cannot do is relate the whole content to the perceivable reality. That's a big no-no, even with large, even with multimodal large language models, I have to say. And and whenever you need to check the factual accuracy, that something was maybe translation looks right, but for instance, LLMs are still famous for not being able to count or calculate things. If a measurement unit was converted incorrectly, LLM might or might not be able to spot. Or we know that this has been mentioned, that human output is also not without errors. Alan Melby wrote sometime in 1982 that machine translation as in 1982 is similar to bad human translation. And also that human generated source content is also not necessarily correct, and LLM definitely wouldn't be able to detect these kinds of error where the content, either the source content or the translation or both, is at odds with reality. So that would be the biggest no-no. And other than that, LLMs are pretty flexible, and I don't think we have found out where the actual limitations are. I was speaking about something that I know to be true.
Yeah. I would say that the right way to think about errors is some of the requirements are not met, and we can see that there are specific types of requirements that are not met by neural machine translation, like for example, neural machine translation learns only on good translations. Well, in some cases, just some things you should not translate it in this way. Like actually, many companies in marketing have a list of things they should not say in marketing in certain markets related to some history or some local culture, and that's what LLMs can do, because you can actually train them on what people were changing, right? Another good example is any kind of context-dependent requirements, or when requirements missed as context-dependent mistakes around tone of voice or around, for example, gender, when some specific person or some specific company is mentioned. There are lots of languages which heavily use grammatic gender, and you have to pull this context, you have to check that it follows this metadata, you have to fix it. So those kind of errors are some of the examples.
Yeah, definitely. We have a few more minutes, so I think I'm going to try and squeeze one more question in. I saw a poll pop up as well. I think everybody's been starting to answer that, so thank you very much. Let me just have a look to see if I can find one last question to answer.
And maybe we will, Marilyn, I think we can answer also some of them offline and then just share them, the document.
Yeah, definitely can do that. I think, have any experiments been done with different measurements of MT to determine its usefulness rather than quality? So, for instance, SEO efficacy for websites or product-related content. Have we looked into, I think if I reformulate that question, have we looked into machine translation or GenAI for the purpose of not necessarily content quality, but SEO efficacy, or different goals it's trying to achieve?
Well, I maybe can quickly provide one added what we have is that we deal a lot with customer support cases where the goal of translation is to help a person to resolve a problem, and we had a few situations. So we measure that there is a typical through direct user feedback where they kind of specify was the translation helpful. And at some point, we figured out that it's a separate metric, and sometimes it even disagrees with linguists. We had the situations when the opinion of linguists and users were very different about what's the best translation for this question, for this response from support agent.
Definitely. Great. All right. We are at time. Thank you, everyone, for watching. It's a lovely way to conclude today's webinar, I think. Thank you, Balázs. Thank you, Konstantin.
Thank you very much.
Thank you, everyone, for asking questions as well. Have a lovely morning, afternoon, or evening, depending on where you are. And we hope to see you next time. Thank you.
Thank you very much. Thank you for having me. Thank you, everyone.
Thank you.
Bye.
Bye.